Welcome back. Our topic this week is heating and cooling systems, and we're going to be talking in this video about cooling systems. Bringing it back to our overview of different climate zones in California, you can see everywhere that I've tagged with this green area are times of year where your occupants are going to be uncomfortable unless you add some ventilation or mechanical cooling. All right. And then tagged in this light blue are areas which ventilation really isn't going to help. All right. Not enough at least. And you could use mechanical cooling. That's your air conditioning, your typical air conditioning. Or in this specific area, because they are in the dry side, you can also use evaporative cooling. Don't forget comfort. Thermal comfort is the ultimate goal of your cooling systems as well as your heating systems. We're going to start out with the passive cooling systems, in this case ventilation, and then move into the more active or mechanical systems. Those are going to be your traditional air conditioners. So a focus on ventilation. Ventilation is going to be the least expensive and the most energy efficient way to cool a home. So you're going to want to use it the most. The most efficient way is going to be natural ventilation. Open up a window, let a breeze in. All right. Using a little bit more energy is going to be fans, and finally also whole house fans. Natural ventilation can be as simple as opening up a window in your home, but it can be a little bit more complex design based on the stack effect. This is the name for realizing that hot air rises. And so by providing a place for the hot air to escape from in the top of your home, you are able to draw in the cooler, lower air and cool your home naturally. You can also design your home for natural ventilation flow. All right. And some good tips and tricks are to provide at least two openings in any particular room or space. Adjacent walls work. Opposite walls work even better. In the same wall can work as long as but it's a little bit more tricky. Okay. And kind of in the vertical direction, what you're aiming for is for a flow across the body of your occupants. And so by providing high openings, you do let the hot air exhaust, which is good, but you don't get that flow across the body of your occupants. Low openings right here will provide a cool flow across the body of your occupants, but you will collect hot air in the top of your room. So kind of your best bet is to provide both high and low openings. You'll get a mix of the air in the room, high and low, and you will still get that cool flow across your occupants. I'm only going to talk briefly about fans because you're probably pretty familiar with fans and their effects on human comfort, all right? Or in this case, Beagle. So the only thing I want to mention is that although fans do cost energy, right? We spend energy to move the fan around. They are a very low energy item compared to air conditioning. And so this is a great place to start your sustainability goals. A whole house fan is a mechanical system, all right, in that, again, we spend energy to move our fan, and but again, it is a low energy system and very, very effective. It will draw the hot air and exhaust it out of your house, and you'll want to also design for the cooler air to allow it into your home. All right. So if you're ever in a house and you see this type of register or grill on a ceiling, that's what you're looking at. It's a whole house fan. Let's move on to your refrigerated cooling systems. These are mechanical cooling or air conditioning. It uses the same process that cools your air inside of a refrigerator. And so the refrigeration cycle will compress and expand a fluid, all right, and transfer heat from one location to another. I'm going to let another video in your module explain the refrigeration cycle to you. But just know that various types of air conditioning systems use this process to cool your building interiors. Air conditioning or cooling systems can be divided into packaged systems and split packaged systems. In the packaged systems, which is this kind of upper illustration here, a outdoor unit is going to directly deliver cooled air into the house. All right. This is in contrast to a split package system. The split package system will have the outdoor unit, again, the compressor and condenser, but it will use a fluid, all right, to transfer or distribute the heat to an indoor unit, which has your air handling unit in your fans, which will then produce the cooled air and deliver it to your rooms. All right. The split package system is the most common residential type as opposed to the packaged system. All right. So let's go into more detail about that one. So starting with the outdoor unit of a split packaged system, that's where your compressor and condenser are going to be. And they're typically located either on a roof or in a side yard somewhere located on a concrete pad. All right. You want to tuck these out of the way. They're kind of loud and ugly. All right. Then we have the indoor unit right here. All right. The cooling or heating coils end up here along with a circulating fan to blow air over those coils and cool or heat the air. All right. The indoor unit is typically located in the garage or a closet or sometimes in the attic, as shown in this example. All right. From the air handling unit, the cooled air is then delivered to the individual rooms through this ductwork. We can see right here, right, and into the room. These split packaged systems can be further subdivided into two different types, the ductless mini splits. I don't know who comes up with these names, all right, and the central air system. So the illustration we just saw on the last slide, and that's repeated right here, is of a central air system. It's going to cool all the rooms that are connected to this duct system at the same time. The ductless mini split right here, here's an illustration of it, is more small and compact, and you usually install one per room. All right, you gain some space because there are no air ducts, but you do have to install more units. Your heating and cooling systems can be two separate systems, and that's what we've been talking about so far. That would be your air conditioning or your cooling system and your heating or your furnace system. All right. And this is done because you can optimize those two different systems for the heating and the cooling. Even though they are two different systems, it's possible to use the same set of ducts. In areas that are much colder, all right, colder climates, it is more efficient to use a gas furnace system, and therefore it's more efficient to use the two separate air conditioning and heating systems. All right. A heat pump is the other option right here, heat pump. A heat pump is going to be a central air conditioning system that can reverse the direction of the refrigeration cycle. right? Refrigeration cycle works equally well both ways, right? So your heat pump will reverse the refrigeration cycle and transfer heat from the inside to the outside. It might not be as effective as a traditional furnace. And that's why you don't want to use it for areas that get really cold, okay? But the positive of a heat pump is that it does not require you to install additional heating equipment, right? Or buy additional heating equipment. And finally, for your sustainability goals, heat pumps don't burn natural gas, and therefore they have zero emissions. Thanks everyone. In this video, we covered cooling systems, what they are, the different types available, and how it ties in to our climate.